Hello friends, today I'm going to explain about the mental health support system that we have worked on, me and my team. My name is James D'Souza. So what was the reason for this system? So essentially in India, mental health education or mental health medical support is very less, and it doesn't reach out to all the sections of the society, especially those who cannot speak English or those who cannot access a doctor because the payment is high. And in most cases, the doctor, like a psychologist or a, a relevant doctor who can speak to these people on mental health, is not available. So the idea was all about enabling the technology to bridge this gap and to reach out to our entire population, let's say India, where many of them speak different languages, where many of them have mental stress and they don't have anybody to reach out to. The best they can reach out to is their parents or their friends, but it is nothing beyond that. So that's why I came up with this idea of having a mental health support system where the technology will be available in the privacy of the room, maybe of a child who is going through a mental stress of his exam, maybe a farmer who is having tension about his paying up the loan. We all have different kinds of stress, and hence we want a system at a India level which can reach out to our population. Whatever solution we give to India, where we support the challenges of languages and culture, can be applied in all other cultures similar to India. The Western stress causes are different from the stress that is caused in India. So we cannot say the mental health support system has to be the same in all countries. It depends on the culture. I personally feel the cultures from the Middle East to the Asia to Southeast Asia, where um, we have communities, a concept of communities, family, and several other factors. The way we live our lives, including China, we have culturally we are little different as to what is important in our life or what is not important in our life. So the stress level is very different on this side of the globe, where countries which are English speaking or maybe developed countries or rich countries are different from from the stress level of the countries which are underdeveloped, which are poor, and they have different kind of challenges. So that is what the inspiration is about this mental health support system. So as I said, we want to create a mental health support system that can respond to a particular person, not only respond but keep seeing, hearing, monitoring, just like a private psychologist. We want a mental health support system not only to detect any kind of mental health issues but also to guide and support in addressing those issues. Let's go with the architecture that we have used in this particular system. So here is an architecture where on the right hand side we are capturing all the data and we are channeling it through systems or softwares which can interpret this data, store it in a database like AWS DynamoDB, where we can try to apply machine learning on this data and detect for any stress levels or any mental health issues. And if the mental health issue is far greater beyond a particular point, we want the AWS Lambda to trigger a response to back to the user, which is indicated by the green line where the response is going back to the particular user. Having said that, this architecture on the right hand side, if you notice, mental health issues can be caused due to stress, which can be caused due to genetics, a trauma, an environment, or a neurobiological effect. We want our devices like smartwatch, wearable devices, smartphone, computer, laptop, or maybe a application like Alexa, a device like Alexa, EEG handband, or vagus nerve simulation to track certain data. So what kind of data we could track? We could track the nutrition data as to what are the foods that we eat, how much water do we drink, the hydration level, how is our breathing pattern, what is our heart rate, what is the sleep data, how much do we sleep. All this data captured from various devices will come in as data which can then be processed to look out for mental health issues. Technically, we are thinking about using AWS cloud, where the AWS IoT core will be collecting all the data that is streamed through these devices. All the data that is coming in has to be filtered, transformed, and stored. Some of the data we can pass it on to the softwares like AWS Health Scribe or AWS Comprehend to interpret data that is coming through conversation. So Health Scribe can be used to interpret the recordings of patients that we are conversing with and to detect for any mental health issues. The user can also talk to the application using a chatbot or maybe through some other means like Alexa, and that can be interpreted by us in this application. So other things that we are looking for is also emotion detection, mental health chatbots, mental health softwares, which may be used in our application. But the idea is ultimately to collect all data in the IoT core, put it in the database, and if there is external mental health data set which is already ready in the market, then we want to upload it on AWS S3 and ultimately into our DynamoDB which can then be used, or maybe the health data is available in the health lake or data exchange. But as I said, since the data set, mental health data set for every country depends on its status as to how well they are doing financially and mentally and culturally. All these elements ultimately adds to that factor, and hence we need our own Indian data set. The SageMaker is the tool that we want to use to implement our ML models, and based on our ML model we want the results of ML model, whatever is the prediction. If the prediction indicates there is a high level of mental stress, then we want to use AWS Lambda to trigger a response back to the user via AWS IoT Core. So that is what our architecture is. As part of this architecture, we have used a technique. Whatever data is inputted from the chatbot, or whatever profile information we get, or whatever brain signals we get, or whatever nutrition information we get, we want the transformer to rank each category in a scale of 1 to 10. So if the sleep is very bad, let's say the user has slept for 1 hour, we want a rating of 1. If the user has slept for 8 hours, the rating will be 8. If the user has slept for 12 hours, the rating will be 10. So 10 is the max that we can get. And same way, we want to come up with ways where we can scale or downscale all the data, or interpret all the data between 1 to 10 ranking. And ultimately, we want to use all these collected data like sleep, brain, nutrition, or any other data like a brain signal or nutrition, as I mentioned over here, or maybe hydration level, or maybe breathing patterns, and convert it into a mental health result which has to be predicted between 1 to 10. So this mental health data transformer is collecting the data in different formats, but ultimately it converts the data into range of 1 to 10. Due to the time constraint, we could not work on all the modules, and we could not even use AWS. So what we did is we went with whatever free tools we had available, and we went with the module of chatbot. So this is the design of the chatbot, where we are using the Next.js web interface to collect profile information, and the Gen AI chatbot we have implemented on, or we have implemented it locally, but here in the design ultimately we want it to be on Render Cloud. And this program would essentially be responsible to execute the chatbot functionality. The database that we want to use to store all the information is MongoDB. The Gen AI LLM that we want to use is Google Gemini. So Next.js was implemented on Vercel Cloud, MongoDB on the MongoDB Cloud, and the Gen AI Python program was implemented using Flask on Render Cloud. Our web interface would be a place where user can initiate the chatbot, but also can provide profile information such as how much sleep is he getting, what is the nutrition he is having, what are his habits, and various other indicators that can indicate what could be causing the stress or the mental health issue. This table shows the input to machine learning program where every feature is scaled between 0 to 10. So the features that we considered in this phase was sleep, nutrition, brain, data, physical health and hydration. Based on this, we came up with a mental health result between 0 and 10. For the ease of execution, we took an average of all these features and we produced a result. Since we don't have a mental health data set, we used our own mental health data set. So here you see we created a data set where for every possible values of sleep, that is between 0 and 10, within that we have created for every possible value of nutrition, then brain, physical health and hydration. In the end, the mental health is the average of everything. And in this way we use this simple Python program to create the data set. If you look at the data set, so it is a 26, almost 27 MB data that was created using this program so that we could test our machine learning model. So this is a very big data set, but here if you see, let me see if I can open this in Notepad. So here you see the data that is created. The columns are sleep, nutrition, brain, 0, and this runs from 0 to 10. And this runs, and lot of all the combination that is possible between 0 and 10, we provide that and we create the average over here. So this is how we created the data set. In the end, definitely we have 10, 10, 10, 10 and 10.0. So every possible combination is covered in this way. We use this data set to pass it through our machine learning program. So here we are reading the file and we are loading the data set, and then we mention what are the features and target, and we apply linear regression model, and based on that we get a predicted result. As you will see, the plot shows the graph of data between predicted result and the actual result. So the predicted and actual result are exactly matching, which means this linear regression model is working perfectly as far as our data set is concerned. In the future, we want to capture real-time data using this model, and which will help us to detect mental health issues. So here, as we see in the slide, if the value is greater than 5 or less than 5, which means it is a poor mental health, and we want to trigger a response through our AWS Lambda function back via the AWS IoT core to the user, letting him or her know that you have a poor mental health status and we need to take care of it. You can improvise on your sleep, maybe you can improvise on your nutrition, brain. We can give these results, this particular raw data to that particular user as to how he is doing well as per the system. If it is greater than 5, it means the person has a good mental health and there is nothing to respond back. So these are some chatbot screens where the user is typing. We have tried to integrate the local Indic language and see if the chatbot responds. And we did find locally that when we implemented this chatbot, though the input was in English, we could get a response in Hindi. This is the web interface through which we want to collect our profile information. It is not necessary that the profile information is collected through the website only. One can create the profile information using the chatbot or maybe a calling agent. So that's it for now. You can watch the demo videos of chatbot